This is SpaceTime, Series 28, Episode 10, for broadcast on the 22nd of January 2025. Coming up on SpaceTime, Gaia, one of the most important astronomical missions ever undertaken, finally completes its sky scanning phase. The first ever detection of a mid-infrared flare from the Milky Way supermassive black hole, and discovery of a strange new type of planet, unlike anything in our solar system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Well, it was one of the most important scientific missions ever undertaken. The European Space Agency's Milky Way mapper Gaia spacecraft has finally completed the sky scanning phase of its journey, in the process changing our understanding of our galaxy. The 2,000-kilogram probe has racked up more than 3 trillion observations of about 2 billion stars and other objects over its past decade of operations. In the process, it's revolutionized science's understanding of our home galaxy and its cosmic neighborhood. Launched back in December 2013, Gaia is now almost out of fuel. It uses about a dozen grams of cold gas per day in order to keep it spinning with pinpoint accuracy. That spinning allows it to be stable, allowing it to focus on its primary mission. Technology tests are now scheduled for the next few weeks before Gaia is moved into a sort of retirement orbit, where future missions will be mapped out. In the meantime, 2 massive data releases from Gaia have already been tabled, one for next year and another for the end of the decade. The treasure trove of data collected by Gaia has given astronomers unique insights into the origins and evolution of our Milky Way galaxy. See, Gaia's been mapping the positions, distances, movements, brightness changes, composition, and numerous other characteristics of billions of stars, repeatedly monitoring them with its 3 instruments over the course of its mission. This has enabled Gaia to deliver on its primary role, building the largest and most precise map of the Milky Way, showing our home galaxy like no other mission has ever done before. In fact, it's given us the best reconstructed view of how our galaxy might look to an outside observer. This new impression of the Milky Way incorporates Gaia data from a multitude of papers over the past decade, and it contains major changes from previous models. Even basic ideas have been revised, such as the rotation of our galaxy's central bar, the warp in the galaxy's disk, the detailed structure of our spiral arms, and interstellar dust near the Sun. Gaia's repeated measurements of stellar distances, motions, and characteristics are key to performing galactic archaeology on our Milky Way galaxy, in the process revealing missing links in our galaxy's complex history, helping scientists better understand its origins. From detecting the ghosts of other galaxies that have been cannibalized by the Milky Way and multiple streams of ancient stars that merged with the Milky Way early in its history, to finding evidence for an ongoing collision with the Sagittarius dwarf galaxy today, Gaia is rewriting the Milky Way's history and making predictions about its future. In the process of scanning the stars in our own galaxy, Gaia's also spotted other objects, ranging from asteroids in our solar system to galaxies and quasars, the bright and active centers of galaxies powered by monstrous supermassive black holes outside our Milky Way. For example, Gaia's provided pinpoint precision orbits for more than 150,000 asteroids, and it's had such high-quality measurements, it's even been able to uncover possible moons around hundreds of these asteroids. It's also created the largest 3-dimensional map of about 1.3 million quasars, with the furthest shining bright when our universe was just 1.5 billion years old. Gaia's also discovered a new breed of black holes, including one with a mass of nearly 33 times that of our Sun, hiding in the constellation Aquila, less than 2,000 light-years from Earth. It's the first time a black hole of stellar origins this big has been spotted within the Milky Way. We've already had 3 data releases from Gaia, and they've changed our understanding of the galaxy. Data Release 4 is expected to contain some 500 terabytes of information covering the first 5.5 years of the spacecraft's operations. Data Release 4 will also expand its binary star catalogue, the largest such catalogue to date. That's because Gaia has the unique ability to tease out tiny motions in pairs of celestial objects orbiting close to each other, and it's already spotted previously hidden companions around bright stars. Gaia's exoplanet discoveries are also set to increase with the forthcoming datasets. That's thanks to the longer frame time of observations, making it a lot easier for Gaia to spot wobbling stars. They're stars that are gently being tugged by the gravitational perturbations of orbiting planets. It's been a fascinating mission so far, and although the data collection's now coming to an end, the astronomers sifting through the data for the next two releases will undoubtedly make discoveries that'll revolutionise our understanding of the cosmos. This report from ESA TV.
What does the Milky Way look like from the outside? No spacecraft can travel beyond our galaxy, so we can't take a selfie. But during its lifetime, Gaia made 3 trillion observations of 2 billion stars and other objects, giving us the best insight yet of what our home galaxy looks like. Gaia showed that our galaxy's disk is warped and wobbles, possibly caused by a collision with another smaller galaxy. Moving further out, Gaia also studied other galaxies around the Milky Way, such as the large and the small Magellanic Clouds, and 40 other companions. Gaia revealed our galaxy's turbulent history by tracking the movements of streams of stars. Gaia gives a unique view of our Milky Way, scanning our galaxy from the inside out, building a more detailed map than ever before, fundamentally changing what we thought we knew about our home galaxy, where our sun is embedded among billions of stars.
This is SpaceTime. Still to come, the first ever detection of a mid-infrared flare from the Milky Way supermassive black hole, and discovery of a strange new type of planet unlike anything ever seen in our solar system. All that and more still to come on SpaceTime. Astronomers have made the first ever detection of a mid-infrared flare emanating from Sagittarius A star, the Milky Way's central supermassive black hole. The observations reported on the pre-press physics website archive.org are based on data collected by NASA's infrared Webb Space Telescope. Located some 27,000 light-years away, Sagittarius A star has about 4.3 million times the mass of our Sun, and it's the central pivot point around which our entire galaxy rotates. Sagittarius A star regularly exhibits flares that can be observed in multiple wavelengths. That allows scientists to see different views of the same flare and better understand how it emits light and how those emissions are generated. But despite a long history of successful observations and even imaging the cosmic beast using the Event Horizon Telescope in 2022, one crucial piece of the puzzle, the mid-infrared observations, have been missing until now. Infrared radiation has longer wavelengths than visible light, but shorter wavelengths than radio. And mid-infrared sits in the middle of the infrared band. It allows astronomers to observe objects like flares, which are often difficult to observe in other wavelengths because of the impenetrable clouds of gas and dust which block out the view from Earth. See, until this study, no one had yet successfully detected Sagittarius A's variability in the mid-infrared. That left a gap in science's understanding of what causes these flares, and therefore raises questions about whether the theoretical models of the supermassive black hole are actually complete. One of the study's authors, Joseph McHale from the Harvard Center for Astrophysics, says Sagittarius A's flare evolves and changes quickly, in just a matter of hours, and not all these changes can be seen at every wavelength. For over 20 years, astronomers have known what happens in the radio wave band and what happens in near-infrared light, but the connection between them, the mid-infrared, was never 100% clear or certain. McHale says these new observations in the mid-infrared fills that gap and connects the two. Mind you, scientists still aren't 100% sure what causes these flares, so they rely on models and simulations, which they then compare with observations to try and understand where it's all coming from. Now, many simulations are suggesting that flares in Sagittarius A star are being caused by the bunching up of magnetic field lines in the supermassive black hole's turbulent accretion disk, a disk of matter surrounding the black hole's event horizon, on which material is being crushed and torn apart at the subatomic level before falling beyond the event horizon and into the singularity of the black hole. When two magnetic field lines approach, they can connect to each other and then release a huge amount of energy. Now, the byproduct of this so-called magnetic reconnection is synchrotron emissions. That occurs when energized electrons travel at speeds close to the speed of light along the magnetic field lines, and they can emit the high-energy photons powering the flare. But because the mid-infrared spectral range sits between the sub-millimeter and near-infrared, it keeps its secrets locked away about the role of electrons, which would need to be cool in order to release energy to power the flares. The new observations are consistent with the existing models and simulations, and that adds another little piece to the puzzle, supporting the theory of what lies behind the flares. The research indicates that there may be a connection between the observed variability at millimeter wavelengths and the observed mid-infrared flare emissions. Simultaneous observations using the sub-millimeter array telescope, the nuclear spectroscopic telescope array NuSTAR, and the Chandra X-ray Observatory filled in the additional part of the story. Sadly, no flares were detected during the X-ray observations, likely because this particular flare simply didn't accelerate electrons to high enough energies. But the team was successful when they turned to the sub-millimeter array, which detected a millimeter wave flare lagging roughly 10 minutes behind the mid-infrared flare. It all adds to the puzzle picture. This is SpaceTime. Still to come, astronomers have discovered a strange new type of planet unlike anything in our solar system. And later in the science report, a new study suggests that carrots can improve the treatment of type 2 diabetes. All that and more still to come on SpaceTime. Astronomers have discovered a strange new type of planet unlike anything ever seen in our solar system. The findings, reported in the astrophysical journal Letters, are based on new observations by NASA's Webb Space Telescope combined with simulated computer models. The amazing discovery provides another piece to the puzzle of understanding how planets and planetary systems are formed. Now, so far, more than 5,000 exoplanets, that is, planets orbiting around other stars, have been confirmed. And many are unlike any of the planets in our solar system, making it difficult to guess what these strange worlds are like. One of the most common types of exoplanets falls into the size range between the Earth and Neptune. Now, astronomers have been debating whether these planets are Earth-like rocky or terrestrial worlds, but with thick hydrogen-rich atmospheres, or whether they're more Neptune-like icy worlds, surrounded by water-rich atmospheres, the so-called water worlds. Problem is, previous studies have all been confounded by layers of thick, high clouds, which seem to be a common feature on these types of planets. That makes it difficult to study the atmosphere below the cloud deck. And that's where the Webb Space Telescope comes in. Astronomers used Webb's infrared capabilities to peer through the clouds on one of these strange worlds. The planet, called GJ1214b, is located just 48 light-years away in the direction of the constellation Ophiuchus, and that makes it relatively nearby and consequently one of the easiest examples of this kind of planet to study. As astronomers looked at the data, they were shocked to find that instead of a hydrogen-rich super-Earth, or for that matter a Neptune-like water world, the new data revealed concentrations of carbon dioxide comparable to the levels found in the dense CO2 atmosphere of Venus. The study's lead author Everett Shulin from the University of Arizona says the discovery was a surprise and there are many uncertainties still in the data. The problem is the detected carbon dioxide signal from these observations was only tiny, so careful statistical analysis needed to be carried out to ensure that the signal was even real. The authors used theoretical models to run a plethora of what-if scenarios about the likely atmosphere of the planet in order to match the Webb observations. And out of all these models, the ones which best fit the data suggest a carbon-dominated atmosphere, very much like planet Venus. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Scientists have calculated that around 465,000 tonnes of methane were emitted from the Nord Stream subsea pipeline when it was sabotaged and damaged in 2020. The findings, reported in the journal Nature and Nature Communications, are based on 3 separate studies. This is the largest recorded amount of methane released from a single transient event. Disturbingly, however, it only represents 0.1% of anthropogenic methane emissions for 2022. In the Nature paper, the authors found around 465,000 tonnes of methane were emitted into the atmosphere, equivalent to about 1.2% of all emissions from natural gas and 0.3% of methane emissions from agriculture. An accompanying Nature Communications paper suggests that some 14% of the Baltic Sea experienced dissolved methane concentrations 5 times greater than average natural levels. In fact, it may have impacted up to 23 marine protected areas. A second Nature Communications paper looked at the secondary release of methane into the atmosphere after being dissolved in the seawater, and it looked at the distribution of that methane which escaped from the pipelines. A new study suggests that eating carrots can improve the treatment of type 2 diabetes. You see, carrots enhance the body's ability to regulate blood sugars, and they positively influence the composition of gut bacteria. Type 2 diabetes treatment typically involves dietary changes and medication, though many people experience side effects from the pharmaceuticals. A report in the journal Clinical and Transitional Science found that carrots could offer a natural and potentially side effect-free way to complement existing treatments. The authors studied the effects of carrots over 16 weeks on 2 groups fed a calorie-matched diet. One group were given diet supplements which included 10% freeze-dried carrot powder, and the results showed that the group receiving the carrot powder exhibited improved blood sugar regulation as measured by glucose tolerance tests. The study showed that carrots altered the composition of the gut microbiome, the billions of microorganisms living in the gut that play a crucial role in digestion and health. Carrots contain bioactive compounds that enhance a cell's ability to absorb sugar, thereby aiding in blood sugar regulation. These bioactive substances derived from unsaturated fatty acids are also present in other vegetables from the carrot family, including parsley, celery, and parsnips. While it might not be easy to insert it into your ear, scientists at Meta claim that your smartphone could soon be the equivalent of the fabled Babel fish from The Hitchhiker's Guide to the Galaxy. See, in Hitchhiker lore, the Babel fish was a small fish capable of real-time language translations. While most existing machine learning translation systems are text-oriented, or they involve multiple steps, often translating speech into text and then converting it into speech in another language, the new model, called Seamless M4T, does immediate speech-to-speech translations covering 101 languages. A report in the journal Nature claims the new artificial intelligence model is capable of filtering out background noise and adjusting to speech variations, with 23% more translation accuracy than other translators. Australia's largest telecommunications company, Telstra, has just signed on to SpaceX's Starlink broadband internet satellite service. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, now late last year, the New Zealand company 1NZ announced that it was launching satellite connectivity for regular mobile phones, in this case the Galaxy Flip 6, the Fold 6, the Galaxy S24 Ultra and the Oppo Find X8. Funnily enough, no mention of the iPhone there that's had emergency satellite capabilities for the last couple of years with the iPhone 14 onwards. But Telstra's announced that it is bringing what is known as direct-to-handset or satellite-to-mobile text messaging to customers in Australia. And this is going to be for those people who don't have mobile coverage. It's not launched yet. It's launching later this year. The boilerplate text says that any LTE, or which is a 4G phone or above, can do this. But given the New Zealanders only specified a certain number of phones, we're yet to see what Telstra is going to be offering. But satellite connectivity is going to eventually also extend to data. Now, this won't stop the 4G, 5G and 6G networks being rolled out. You get much faster connectivity ping times, but it'll fill in all the black spots. And 2025 and onwards is the year that the tyranny of distance is yet once again smashed into ever greater irrelevancy.
Is this just with Starlink or is it with other satellite providers as well?
Look, so far it's only with Starlink, but Amazon is launching a whole bunch of satellites. China's launching satellites. Eventually there'll be other constellations that can do the same thing as well. But Elon Musk has been launching rocket after rocket on SpaceX, and Starlink has been launching version 2 satellites that can do much more in terms of bandwidth and data and speeds and latency. So Elon Musk Starlink is first, but others will undoubtedly follow.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.